Hello all, welcome to my 8th lecture. In this lecture, we will see how to kickstart your project development using two different approaches for C2000 microcontrollers provided by Texas Instrument. So I have referred a software manual, which is provided in this particular link to create these two different environments. So this is the guide provided by Texas Instrument. So here you can see two different methods. One is your driver library based approach. So where you'll try to use this particular folder, driver library. Another one is the bit field. So in the bit field, we will try to use the device support folder for developing your projects. So in the previous lecture, we have discussed about the important files or what is the purpose of each and every file we try to discuss. So if you do not watch my previous lecture, I highly recommend you to watch the entire video series, not directly get into this video. And then we are having some approach called driver library. So now let's try to create a project with both two different methods. I'll try to create the project with first the bit field. So file, new CCS project. I'll try to create or browse a folder called bitfield project. I'll create it, browse the folder, and then maybe I'll try to say it is bitfield based project. So I'll try to put that as well. Yes, so once you do this, you can see automatically the main.c file got generated. And and also you can see while you're creating the project itself, there is something called, if you try to see the build, there is something called generate make files automatically. So here we are trying to say that we are not having our own make file. We are trying to generate a make file which is provided, or use a make file provided by the Texas Instrument, right? So now we will try to put the important files. So we have discussed the important files, like one is the header file folder, and then the flash linker command file, device.h file, code start branch.ism, the global variable definition, non-bias.cmd, and the microsecond delay.ism files. So I'll just try to copy the different files, and then I'll try to put it inside this project. So now you can see the different files are, is a part of this particular project. And one more thing, what you want to do is the code start branch, So we can see this code start is a starting portion of the code. So you have to go to properties. So you have to go to properties. So you can see different options. So build is nothing but it's like a compilation. So you can see the different options, the optimization, what is required, what all files you want to include. There are different other options which is given. Linker is the after the compilation, which memory location you want to go. Such things are given over here. So advanced option. So you can see there is something called the simple management, specific program entry for the output module. So once you, after the reset, where you want to start. So here you want to mention, you have to give this path as the code start path. Okay, so I have tried to give that. Now, if you if you want to, run this project or compile this project, what I'll try to do is I'll try to take some previous example which we have discussed in one of our previous lectures. So I'll try to take this signal processing.c file, the main.h file. Yes, I'll try to take these two files into our project as well. So I'll just copy these two files. I just pasted over here. And then maybe the main.c file, which we have used, I'll try to copy the contents and paste over here. I'll try to open it, and then I'll try to Control C I'll try to replace this main file with this particular, with this particular thing. So we had seen with the VS Code, the Visual Studio Code, how we have used the how we have compiled it. So so I think the the beauty of this particular file is, this platform is ID is, the moment you put the signal processing.c file, automatically the tool will identify all the different source files. So you can see the all different source file will automatically will get included when you try to compile your project. Now when you try to just put the compile, you can see, okay, try to show some errors. I'll try to, oh, okay, it says the device.h file. So, okay, so it is inside the header file folder. So I'll try to, give the path properly. Header files, yeah, header files, device.h. So it's almost the same, like you're trying to do the same thing what you have done with the VS Code. Only thing is, now if you see the global variable definition.c file, now this compiler will try to understand the hash pragma means it's the it will try to understand this access protection rec. It should go to this access protection rec files, and in the non-bias.cmd file we can see this access protection rec files will should be aligned with access protection. So it will try to align this, and then we are having this code start branch.ism, and then I also try to use the flash linker command file where we are seeing this begin, the begin, the code start should go to begin. All right, so we are able to see this. So you can very well use this platform now to add more source files, include header files, like whatever we need, right? So basically, the different structures, whatever declared or provided by the Texas instrument, we have included that. And inside the device.h, we have include the all the different header files, and also we have defined some user defined data types. So this is one thing what we have done. And then the global variable devs.c, which is the which is creating the structure instances, and then non-bias.cmd, where we are trying to give the memory location for each and every structure instance what we have created. And then the linker command file basically will, once you compile it, it will say, which portion of the code has to go to which particular place, right? Now, once you do this, you can see in the debug, it will, you can see it generate some like dot out file, and also you can see generate some map file, dot map file. We'll try to, discuss in the next lecture what is a map file. We'll try to show with some more examples. So this is one approach. The next approach is something called a driver library method approach. I'll try to create another project. Maybe I'll try to create one like browse. I'll try to maybe create one folder called as driver lib, right? So I have copied this, and then I'll try to say it's a driver library project. So this is the next approach. So in this approach, what we want to do is like you can see this particular folder, driver library, F280015 driver library. So here you can see the INC, the include this complete folder you want to copy. I'll try to explain, like what is this, what is this folder means. I'll try to explain in just in couple of minutes. So driver library, I will try to paste the, try to paste this called as include. Then what I'll try to do is I'll try to, so copy include files, copy all header file source and header files under a folder. So this is the next thing what you want to do. So I'll try to do this thing. Next step is try to create a folder. Maybe I'll try to create called as lib. I try to create lib. And now what you want to do is you try to copy the different, like the entire library file. So I'll start with etc.c all the way till the xbar.h file, and then I'll try to paste it inside this particular, inside this particular folder, right? So now you can see the library is getting included, and inc also getting included. You can also do a different method, like you can try to refer this particular location, and then you can, it is a different approach, but I always recommend to try to copy it locally to a particular folder, and then you try to do it, right? So where we have reached, we have create copy all driver and source files under a folder, and create a header file, and include all driver library header files here. So what we will do is we'll try to create one driver library.h file. So I'll try to create one driver library.h file, and I'll try to create this file new. So it's just a header file named as driver lib, driver lib.h. Now what I'll try to do is I'll try to try to include the different files, different header files inside the library has to be included, right? So what I'll do is I'll do something like this. What we are trying to do is we are trying to say from the main.c. Okay, sorry, this is not the main.c. I'll try to close the other files, whatever we have created. So I think, this is main.c. So we have this driver library.h file. So I think I should just compile it. So it will give you some error. So it's driver library.h file. So I think there is a small spelling mistake, which I try to correct it. Okay. Driver library, and inside this we are trying to copy copy all the or include all the different header files. So we have done that part. Now next what you want to do is you want to write your different functions. So one is the disabled watchdog. So if you try to refer any of the examples provided by TI with driver library based, they will try to use this first statement. So this is nothing but you are disabling the watchdog. So if you try to do it, we can see this particular function is defined in a header file, right? So it will automatically the function, once you call it, it will automatically the definition will be found. The next step is you want to set the clock. So set the clock is basically whether you need a crystal, what is the clock frequency, such things. So I try to show you, or I took some example device set configuration where I'm trying to say it's crystal, I multiplication, reference division, zero division, PLL enabled some settings. I don't want to go in detail, but if you really want to understand, there are two ways. One is you can try to go to the examples provided by Texas Instruments. So here what I'm trying to say is you try to go to the driver lib F2 page examples. You can see there are different examples they have given. So if you try to go to ADC, it will try to show you how does the different examples with ADC. If you want to go to system control, it will try to show you the system clock, things like this. So now I try to define the next function, system set clock. So once you define it, you can, you can see, what is the function definition inside this function. So if you really want to understand in detail, you can try to just search it. Then it will try to show that there are some different places. One is the system clock.c file, another is this system clock.h file, where where the we are trying to say that this function is something like called as extend, right? So here you can see the description, what does the config means. You can see some detailed explanation you can see in this place, right? So that is what next. Then what we will do is, like, we will try to copy, like the other some basic things. I don't want to go in detail, but I just would like to show you some basics. So next is the speed clock. So you like the low speed clock, what is the low speed clock required? Enable peripheral. So if you want to enable the different peripheral, like you want to really give peripheral by peripheral, so you can see the timer 0, timer 1. So the nm will automatically will be identified by the compiler. So this is what the next step. And then the GPU set configuration. So if you want to use a GPU, so there are different options, right? So like a GPU can be used as GPU 0, PWM1, CAN RX, output X bar. So there are different options. So for GPU 0, if you want to use it as a GPU 0, then just select this macro. So if you really want to understand how does this happen, then basically if you try to go through, you can see here. So basically that particular address will be uh, will be given and directly to the address you are trying to write. So once we declare the pointer, maybe you will try to understand in detail. But if you try to go through, you can see the you can get some good understanding of this, this function. How does it really work? So basically you will have something called the GPU control base. So that is a start address. From that start address, how many how many if you want to go to mux or to gmux, the particular location will be shifted, and then you will try to write directly to that particular function, right? So this is the GPU set configuration. So next is GPU set direction mode. So you just mention the pin number and then just mention. So basically this platform, it's super easy to kickstart your project because it gives you everything like ADC.C, whatever the functionality, what is required for ADC is given. What is the V reference, offset, if you want to do offset trim, every functions, like everything will be given. And adc.h file, if you have some nms, everything is given here. And also you can see some static inline functions. You can see here the SOC trigger, everything required for ADC will be given. Same thing with all peripherals, memory, everything will be given. And if you really want to understand, then try to take that example, then try to write. So now, what are the files? What is required for this driver library based project is, you want these two. So I think we have included these two. What we need is generic flash link.cmd and the code start branch.asm file. So I'll try to copy these two files as well. So the one is the generic one, another is the code start branch.asm. So I'll try to copy this to the driver library, and then I'll try to paste here. And then what I'll do is I'll try to go to properties and then advanced options, linker, and then the simple management, and then I'll try to give the same code start, apply and close, right? So now you should be able to compile the project. So you can see the compilation, how happened successfully. And and you can see the, there is no need of the global variable definition. There is no need of the non-bias.cmd file. And you can see the, the dot out file and the dot map file. So these are the two different methods how you can really kickstart your project. I did not took any unwanted files. I just try to take whatever the files which are really required. And in my previous lectures, I tried to explain you what all are the, what does that each and every file means. I hope this was an interesting lecture for you. Thanks for watching this video. We'll meet all in my next lecture.